Intercept is where the graph crosses the x-axis, and the y-intercept is where the graph crosses the y-axis. And remember, we said last time that to find the x-intercept, you're going to let y equals 0, and to find the y-intercept, you're going to let x equals 0. All right, and then if you look at this example, let's suppose you want to graph 2x minus 5y equal -10, let's say. Now, remember, this equation is a linear equation. What makes it linear? What makes this linear? The variables have what exponents? 1. All right. An example we gave last time was where one of the variables had an exponent 2. The x squared, it was had exponent 2. That's not linear. That's quadratic. And we're going to look at that later on today. But everything we've done so far has been linear. All right, so they want you to graph this, though, by using intercepts. So always make sure you follow directions. So don't use a t-table. You use intercepts. So to find, let's do the x-intercept first. To find the x-intercept, you're going to let, what do you let? Y equals 0. So the term that has y in it, that kind of, you can cover it up. And remember, 5 times 0 is still what? 0. Now, if I cover it up, because that term is now 0 since y is 0, what equation do you see? All right, and all you got to do now is just solve for x. So what's x? -5? All right. And it's going to ask you to put it as an ordered pair. So as an ordered pair, that's where you got to put the x and y coordinate. So what's the x coordinate? -5. What's the y coordinate? 0. Make sure you write as -5, 0. It's not 0, -5. It's -5, 0. Because x is -5, y is 0. Now to find the y-intercept, you're going to let x equals 0. So this time, 2 times x becomes what? 0. So what equation do you see? Right? And then to get y by itself, I'm going to go ahead and rewrite it. And so to get y by itself, you can divide both sides by what? -5. -5 divided by -5 is 1. 1 times y is y. And what's a -10 divided by -5? 2. So as an ordered pair, what is the y-intercept? 0, 2. All right, 0, 2. So remember the x-intercept, y is 0. The y-intercept, x is 0. And then all you do now is just plot those 2 points. So remember last semester when you did this, all you did in my math lab was you put a dot where the x-intercept needs to be, you put a dot where the y-intercept needs to be, and then it automatically graphed the line for you. Remember that? Mm-hmm. Okay. All right, if any of you need more graph paper, here. This is the small one, this is the bigger one. Let me get a couple of those. The big one, small one. All right, so then you would plot those 2 points. All right, so you plot the point -5, 0, which is here. That's the x-intercept. And if it says label, what must you do? And it does say label in your worksheet. So what do you do? Put the ordered pair there. So you're going to say -5, 0, just like this. And then the y-intercept is 0, 2. So that's on the positive y-axis. And label. And then you just, now in my math lab, you remember you would click on the on the graph icon, and then you put the two intercepts, and it draws it for you. But on the test in the worksheet, you actually have to draw it by hand. Don't forget to draw the arrows, though. All right. Okay, so there's the graph. Now, from last semester, they didn't ask you this in this section, but last semester, what kind of slope is this? Is this positive or negative?
Negative.
Oh, positive. Your line is rising. Whenever the line rises, the slope is what? Positive. You go from left to right. Okay, so the slope will be positive there. All right, now let's look at this one. This will be next example. All right, let's call this example 1. This will be number 2. All right, suppose you have y equal 2x minus 9. Y equals 2x minus 9. All right, again, you want to use intercepts. Don't do a t-table. Always follow the directions. You got to plot the intercepts and then draw your line. You do the same thing. You're going to say to find the x-intercept. You're going to let y equals 0. All right, now, when in the previous one, when I put my finger on the term negative 5y, you saw an equation. You saw a left side and the right side. The left side was 2x. The right side was negative 10. Here, though, if y is 0 and I put my finger over it, it may confuse some of you. You may say, well, there's nothing there. Well, there is something there. What's on that left side? 0. The right side is what? 2x minus 9. So you got to say 0 equals 2x minus 9. And then you solve for x. So how do you get x by itself? No, not yet. You got to add 9 to both sides first. All right. Always get rid of the coefficient of the variable at the end. So you can add 9 to both sides. You all agree you're going to get 9 equal 2x? Or 2x equal 9, does not matter. And now divide by what? 2. And so x is what, 4.5? Okay, 4.5. So there's x. So there's your x-intercept. So as an ordered pair, what do you write? 4.5 comma 0. All right. Okay. To find the y-intercept, you're going to let x equal 0. All right, now this one's easy to just put your thumb over to your finger. So if x is 0, 2 times 0 is 0. So what's the equation that you see? Y equals negative 9, and y is already by itself. So you're done. As an ordered pair, though, and it will ask you to write this as an ordered pair, so what would you put in the blank? In parentheses, right? Okay, so 0, negative 9. All right, so don't just put 0, comma, negative 9. You got to put parentheses there to represent a point. And then you plot those 2 points. So 4.5, 0. So 4.5, 0 is right in the middle of 4 and 5. So just kind of estimate. You can't see it here. Let me, if I expand it, you could probably see it a little bit better. So 4.5 is about here, let's say. And so that's 4.5 comma 0. And then 0, negative 9 is right here. And then you just draw your line. Make sure you use arrows. And that's all you do. All right? Okay, now, one other thing when you do the My Math Lab, it's not on the worksheet though, but on My Math Lab, here's one, and you may remember this from last semester. But let's look at this problem. So let's see, the graph is on page 2. All right, look at number 3. And there's one similar to this on My Math Lab. All right, so let's suppose you want to graph y equal negative 2x. Y equals negative 2x. And again, the direction says use intercepts. Okay? It says use the intercepts. All right, so to find the x-intercept, you're going to let y equal 0, correct? Mm-hmm. So if I let y equal 0, what equation do you see?
0 equals negative 2.
Y'all agree? And if I get x by itself, you can divide both sides by negative 2. And negative 2 divided by negative 2 is 1. 1 times x is x. X is what? 0. So as an ordered pair, what is your x-intercept? Which is the origin. Okay. To find the y-intercept, you're going to let x equal 0. If I let x equal 0, what do you get?
0.
Y equal 0. And what order pair is that?
0.
0, 0. It's also the origin. Now, when you get to My Math Lab, notice that in the problems we did earlier, the previous problems, the x and y-intercept were different, right?
Mm-hmm.
The x and y-intercepts here are what? The same. So when you plot the x and y-intercepts, previously there were 2 points, and you just drew your line. What's the issue here?
1.
You only get 1 point. How are you going to draw the line if there's only 1 point? So My Math Lab says this. Let me just read it to you. All right, it says this. Use the graphing tool, and the graphing tool is that the one that looks like a line. You just click on it. Remember that? Okay. Use the graphing tool to graph the linear equation. Use the intercepts when drawing the line. And it says for all of them. But then it says this. If only one intercept exists, and only one exists, right?
Right.
It's just what? The origin. If one intercept exists, then use it and another point to draw the line. So you may recall last semester when you did this, all you did was just use the t-table now, and you picked another point for x. Just give me a number for x.
2.
2. If x is 2, y equals negative 2 times 2. So it's y. Negative 4. And all you do now is plot your intercept and what point? To negative 4. All right, so that's what you did. So on My Math Lab in the plane, you're gonna click on the drawing tool. You're gonna click on the drawing tool. You're gonna put the y. You're gonna put the origin as your intercept, and that's the only intercept that you have here. And then you're gonna click on what point? If this is the one you chose. 2, negative 4. Someone else could have said 3 what? If you want to say 3, you could have said y equal negative 2 times 3. Then you would have had to click on what? 3, negative 6. But whatever the other point is, remember the drawing tool, you got to pick 2 points. So you pick 1, 2, and it automatically draws a line. So 2, negative 4, you do this, and then it does what? Your computer does what? Draws the line. That's what your computer does. And you're done. Okay, now on here though, on your worksheet, now remember I didn't give you one like this in your worksheet. But if I did, then you would have had to put the origin and then pick one more point and then draw your line. So we chose what? 2, negative 4? Mm-hmm. And again, you would on the worksheet you'd have to label, so 0, 0, to -4, and then draw your line. But the point here is that on my math lab, it does say use intercepts. The problem with this particular equation is there's only one intercept. There's only one distinct intercept. And so how do you graph the line? You need to do what? Find another point using the t-table. That's how you do it. Okay? All right. And let's see. Make sure. I'm trying to make sure I cover everything. Hit that. Okay. Let's look at this one. Oops. All right. Same thing. You're going to use intercepts, except on. Let's see. This is gonna be number 4. I suppose we had y equals -3 fits x plus 6. And I'm thinking this may be too big. No, I'm good. I think I'm good. Okay. All right. Now remember, they want you to find the intercepts. Now, if in the previous section, if I said a t-table, if I said use a t-table, what values of x would you use for the t-table? What's the first one? 0. All right. And then for the other point, you would use multiples of what? 5. Okay, good. We talked about that last class period. But that's if we use a t-table, right? In this section, though, they want you to use intercepts. So you can say to find the x-intercept, you're going to let y equals 0, correct? Okay. And then, so when you let y equals 0, what equation do you end up with? Tell me the equation. 0 equals -3 fifths x plus 6. Okay. All right. Now, you got to solve for x. Subtract 6 from both sides. That's the first thing I would do. Subtract 6 from both sides. So that would be the easy part to do. So you can get -6 equal -3 fifths x. Y'all agree? Mm-hmm. All right. Now, there are a couple of things you can do at this point. What's one thing you can do? You're trying to get x by itself. Divide by what?
3 fifths.
-3 fifths. That's one approach you learned last semester. What's the other approach you learned last semester? Say it again? Well, that's the same thing. Divide both sides by -3 fifths. But remember, the last semester, the LCD, multiply both sides by the LCD first. So what's the LCD?
30.
No. That's not. That's -6 over 1. What are your denominators? 1 and 5. What's the LCD? 5. So you'd multiply both sides by 5, and then you divide by -3. So I'll do it both ways to show you. Let's go ahead and do the first one that was mentioned. So, no. Dividing by the coefficient. So remember, to get x by itself, if you look at a previous problem we did, so if you look at this one, here when I got x by itself, I divided both sides by the coefficient, right? Mm-hmm. What's this coefficient right here? No, what's a coefficient though? Tell me the coefficient. -3 fifths. Coefficient is whatever you multiply the variable by. So this says -3 fifths times x. So what am I multiplying x by? -3 fifths. And the opposite of multiplication is division. All right, so basically what you're going to do is you're going to divide both sides by -3 fifths. All right. Divide both sides by -3 fifths. Now, You got to remember some things from last semester or the semester before that. Negative 3/5 divided by negative 3/5 is what? 1. So I do get x on this side. That's what I wanted. Now you got to remember how to deal with this, though. When you divide fractions, you take the top fraction, multiply by the reciprocal of the bottom fraction. So someone mentioned multiply by the reciprocal. The same idea here. So what's the top fraction? Negative 6 over 1. And times the reciprocal of the bottom one. What's the reciprocal of the bottom one? Negative 5 over 3. Okay? And then I heard someone say negative 30, although it should be what? Positive 30. A negative times a negative is a positive. So if you did that first, if you said 30 divided by what's the denominator? 3, you would get what? 10. But you could reduce first, right? 3 to 3 is 1. 3 into 6 is 2. So what's a negative 2? This is, y'all agree this is negative 2? And this is negative 5. What's negative 2 times negative 5? 10. Positive 10. So your x-intercept is what? 10, 0. Okay? So that's the approach we took if we divided both sides by the coefficient. Now you could have done this. Go ahead and rewrite this over. So remember last semester, when you solved the equations that had fractions in it, you multiply both sides by the LCD. Now someone said the LCD was 30, they were thinking negative 6 and 5, but negative 6 is not in the denominator. What's in the denominator right here? 1. So what's the LCD? 5. So then what you did was you multiply both sides by 5. So this is what you said. So you said times 5 times 5, just like that, right? And what's negative 6 times 5? Negative 30. Now over here, the 5's reduce. 5's reduce. And what's left over here? Negative 3x. And then how do you get x by itself? Divide by negative 3. And you still get what? Positive 10. So x is 10. Right? It did not matter which approach you took to get x by itself. Usually it helps you mathematically in the future to know both approaches. But you get the same answer. But both approaches could still make an easy a mistake getting to x by itself. You could have somehow made an error somewhere. So you do have to be careful. All right, so as an ordered pair, what is my x-intercept? 10, 0. All right, let's find the y-intercept. To find the y-intercept, you're going to let x equals 0, right? Now that one's easy. If x is 0, let's go back to the equation. I'm going to just go ahead and rewrite it. If x is 0, this term right here is what? 0. And what's y then? 6. All right, so what's my y-intercept? 0, 6. 0, 6. Okay? All right, so the hard one there was finding the x-intercept. All right, and so you plot those two intercepts. So 10, 0 is here. And 0, 6 is up here. And you draw your line. Now, I'm going to ask you the same question I did earlier. What is the slope here? I'm not the actual slope, but is it positive or negative? It's negative. All right, so there's your line. Okay? So when you do the one in my math lab, make sure you look at the steps we did here. All right. Okay, let's see. Oh, and then okay, so in the previous section, we looked at this. something like this. So they had this equation, not the exact equation, but they had this linear equation in two sections, the one with the t-table and the one with the intercepts. Now, on my math lab, though, they're not going to say use intercepts to graph this. It just says, given this equation, use a graphing tool to graph. To graph using graphing tool, remember that the one that looks like a line. To use it, you need to know how many points. 2. So now notice it didn't say anything about using intercepts here. So just use the t-table. Remember what this means? What does that mean? X equals 6. X will always be what? 6. So when you do a t-table, your x column is always going to be what? 6. And how many points do we need? 2. Now, someone said 3 because that's what we said on the worksheet, right? But on my math lab, you only need 2 points when using that tool because it automatically draws it after the second point. So if x is 6, what's y? Give me a value for y. It doesn't matter what y is. 2. If x is 6, give me another one. 4? All right. So remember what that means. This means that x always equals 6. No matter what y is. Okay? And so on the math lab, you would plot the point 6, 2. And then plot the point 6, 4. Oops. And what kind of line do you get? Vertical, right? What kind of equation is horizontal? What must it look like? Y equals. So remember a horizontal line, horizontal, has this form. Y equals a number, right? Right. And remember, in that case, it would say y always equals that number no matter what x is. So it's in the notes from last class period. All right. Now they also have this graph y plus 3 equal 1. Graph y plus 3 equal 1. So again, notice it's linear, but what letter don't you see? X. So what do you think you may want to do here? Get y by itself. So subtract 3 from both sides. What's y equal to? Negative 2. And if you have y equals just a number, there's no x, what kind of line is it? Horizontal. And it's just like the one we just did with x equals. So in a t-table, this says that y must always equal what? Negative 2, no matter what x is. So if y is negative 2, give me a value for x. Okay, if y is negative 2, give me a value for x. 6. And you plot those 2 points and you're done. Okay? So 4, negative 2. 6, negative 2. See this horizontal line? So my math lab, you're going to see one like this where only one variable shows up, but it's not by itself. So it could have easily been something like this. You could have had something like graph x minus 6 equal negative 1. So you got to notice that it is linear because it's x to the first, but the variable y doesn't show up there. So the best way to graph this is to actually do what? Right. So basically you're getting the variable by itself. So you get x by itself. So you're going to add 6 to both sides. And so x equal 5, and now you know what to do. So this says that x always must equal what? 5, no matter what y is. So in your t-table, 5, 5, and just give me values for y. 1, 3. And you just plot those 2 points, you draw your line. Now you always need to know that x equal a number is what kind of graph? What kind of line? Vertical, horizontal? Vertical. So 5, 1 is here. 5, 3 is here. And notice when you draw your line, it's vertical. Okay. And I think that's it. So you should have enough information to do. You should have enough information to do section 10.3. Okay, so that's the one dealing with intercepts. Right, so sometime tomorrow, I'm going to assign 10.3. So I'll give you about a week because there's only one person that still doesn't have access to my math lab. But it's an easy section to deal with. Oh, we're not done. We're done with this section. I know you were hoping. But it's an easy section, so I'm only going to give you about 1 week to do this. Okay? All right. Now, remember the last section we were talking about graphing linear equations using a t-table? All right. And we did some examples in here with the t-table. Let's look at this. Now, we're done with 10.3. We started 10.2. We're going to finish 10.2. 10.2 is the one that had linear equations and that parabola. So we're getting to the point where we're going to talk about graphing a parabola. Okay. Now, the way it's written, though, it looks like this on my math lab. It's written in function notation. So we got to somehow talk about what that means. Function notation. Now, last semester you didn't talk anything about functions. Oh, maybe you did. Okay. I can't remember. So function notation. That's where you had f of x, g of x, or something like that. So let's look at this example. If I had y equals 2x minus 1, okay, this equation, and if I graph this line, let's use a t-table. I'm going to graph this line. If x is 0, what's y? Y would be 2 times 0 minus 1, right? So that's negative 1. Okay? So notice that when x is 0, what's my y value? Negative 1. Right? Okay. If x is, let's say, 2, I get y equals 2 times 2 minus 1, which is 4 minus 1, which is 3. Agree? Mm-hmm. If x is, let's say, negative 1, I get y equals 2 times negative 1 minus 3. Oh, sorry, minus 1. So that's negative 2 minus 1, which is what? Negative 3, right? Okay. All right. Now notice that when x is 0, what was my y value? Was there any other y value for 0? How many y values were attached when x is 0? Just 1. And it's negative 1, right? When x is 2, how many y values do you see for 2 when x is 2?
2.
Nope. Just 1.
Oh.
It's what y value?
3.
3. When x is negative 1, how many y values do you see?
1.
1. What is it?
Negative
Negative 3. All right, so that's going to the idea of what a function is. Now, in this course, you spend very little time in functions. The next course, almost everything are functions in the next course. So let's talk about what the definition of function is. Here's the definition of function. So a function is a relation in which, now a relation is an ordered pair, a set of ordered pairs. So everything we've graphed, all those lines were a set of what? Ordered pairs. So everything we've done were relations. All those equations is a relation. A relation is just a set of ordered pairs. Let's put that right here, a set of ordered pairs. So everything we did last week, everything we did today is a set of ordered pairs. So everything we graphed was called a relation. But not all of them were a function. There were some that were not a function that you're going to see which ones were not. So a function is a relation in which for each x coordinate there is exactly just one y coordinate. So a function for each x coordinate, you better have how many y coordinates with it? Just one. Okay. So this relation right here that I'm pointing to, y equals 2x minus 1, you agree that's a relation, right? Why does it say relation? No.
Because there's a y.
Because it's a set of ordered pairs. You have an infinite number set of ordered pairs here. 0, negative 1, 2, 3, negative 1, negative 3, and so on. It's a set of ordered pairs. The question is it a function? That's a question.
Yes.
Yes, because for each of these x's, you only see what? One y coordinate. So that's a function. So this relation, y equals 2x minus 1, is a function since each x coordinate only has what? One y coordinate. Okay? All right, now, let's look at this one. X plus 3 equal 5. Let's look at that relation. How would you graph this?
Subtract 5 from both sides.
Subtract 3 from both sides. Yeah, subtract 3 from both sides. And I get x equal what?
2.
2. So doing a t-table. That's what we have. Remember, this says that x always equals 2 no matter what y is. So all along my x column, I'm going to have what? 2. And then my y column, I'm going to have what? Some numbers. 0, 7, 5, negative 2, and so on, right? Okay. But it's a relation because it's a set of what? Ordered pairs. Now the question is this relation a function? Okay, so remember the definition of function says what? For each x coordinate, there has to be what? One y coordinate. Well, when x is 2, do I get only one y coordinate? No, I get a bunch of y coordinates. When x is 2, I have 0, I have 7, I have 5, I have negative 2, I have 2.6, I have negative 8.5, and so on, right? So is this a function?
Yes.
No, it's not a function. Because when x is 2, you have more than one y coordinate. So x plus 3 equal 5 is not a function, since when x equal 2, there are more than one y coordinate. Okay. So x plus 3 equal 5 is not a function. So when some of you said yes to the beginning, you were looking at each point individually. But remember, here you did because each of those x coordinates were different. Here, all these x coordinates are the same. So when x is 2, you got to ask yourself, do I really get just one y coordinate? No. There's 0, there's 7, there's 5, and there's an infinite number of those.
So that goes for any number?
Say it again?
So would that go for any number?
What do you mean would that go for any number?
If the x coordinate is, since it's 2, just say if it's 5 or something, if it's 5 all the way down.
Yeah, because for when x is 5, do I just get one y coordinate? No, I get a bunch of y coordinates. Right,
So in other words, it would have to be an equation.
You can only have 0, starting with 0.
You have to have an x and a y in the equation for it to be.
all right. So she's asking. Now remember, we're only talking about lines, though, right?
Right.
She's asking this. So if there's an x and a y, then will it be a function? Well, we're going to look at that. We're going to talk about that. If it's just an x, is it a function? No, it will not be. Because if it's just x, if let's say this was x equal 3, you have 3 all along the x column, and then my y's are different.
Yeah, okay.
It would not be a function. What about if it's just a y?
Same thing,
What do you mean? Would it be a function, not a function?
not a function.
All right, let's look at that.
X's are-
All right, let's look at it.
How would it still be because you're doing it off the integers, right? Like the x, I don't know, the numbers. So they all have to be different numbers. They can't never be the same numbers in the x or the y's, correct? They
Not
can only be-
necessarily. You're going to see. No, that's not necessarily true. So is y equal 5 a function? No? Okay. All right, well, let's think about this. So remember, that says y always equals what?
Always equals
5.
And x can be anything.
X can be anything.
So
Now use the definition of function. For each x coordinate, there has to be what? One y coordinate. So I'm going to ask you, when x is 2, is there just one y coordinate? Do you see? Yes, it is. The only y coordinate for 2 is what? 5. When x is 0, is there only one y coordinate? Yes, it is what? 5.
So it only works if all the x coordinates are the same number.
Yeah. If x is 3, is there just one y coordinate? Yes. It's okay for all the y's to be the same,
Not for the x.
but you can't have multiple. You can't have the same x values with different y coordinates. Okay. Definition of function. Definition of function. For each x, there's got to be what? One y. So when x is 2, there's just one y. It is what? 5. When x is 0, there's just one y. It is what? 5. When x is 3, there's just one y. It is 5. So yes, it is a function. Since for each x coordinate, there's just one y coordinate. Okay. Now, on my math lab, when you do this, the problems dealing with relations and functions, they're going to give you some ordered pairs. Okay? We use the definition of function. What's the definition of function? A relation in which for each there's exactly one y coordinate. Okay. So let's use this example. So I'm using a set of ordered pairs, not an equation, a set of ordered pairs, a finite set. Finite meaning I can count how many ordered pairs there are. I can't count this one because this one has how many ordered pairs? An infinite number. I just did 3 of them. All right, look at this set. That's a set. You use braces to denote a set. So you have this set, and these are my ordered pairs. 3, 1, comma, -4, 2, comma, 0, -3, comma, 2, 5, comma, and let's do one more ordered pair. 8, 10. Okay, write this down. So I have this relation. Why is this set called a relation? It's a set of ordered pairs. How many ordered pairs do you see? 5. So it's a finite set, finite counting. This here's 8, 10. The previous example, that was an infinite set of ordered pairs. This is a finite set. All right, now the question is this. Is this relation a function? You have to use a definition. For each x coordinate, there's got to be one y coordinate. Yeah. Now, one thing you can do is use what's called a mapping. Now, you don't have to use what's called a mapping. You could just look at it and see that for each x there's what? 1 y. But you can use a mapping. You don't have to. And so basically, this first oval would be your x, and the second would be your y. So what's the first x coordinate that you see? 3. It gets mapped to what? 1. So as we do this, notice the arrows. So in order for it to be a function, there's got to be just one arrow coming from that x. So when x is 3, there's only one arrow coming from it. It's what? 1. When x is -4, there's only one arrow. It's what? 2. When x is 0, one arrow. It gets mapped to what? -3. When x is 2, it gets mapped to 5. And when x is 8, it gets mapped to 10. So notice that for each x coordinate, there's only what? One y coordinate. All right. So this is a function. So yes, since for each x coordinate, there is only one y coordinate. All right, let's look at this one. We look at another ordered pair, set of ordered pairs. All right, so this time, let's say we had -2, 3, 4, 6, 7, 3, 0, 1, and let's say -1, 2. All right, so is this a function?
No.
Someone says no.
Yes.
All right. Your definition for each x coordinate, there's got to be what? One y coordinate. So let's look at this in terms of a mapping. So the person that said no, a mapping might help you. Okay? So let's look at this in terms of a mapping. When x is negative 2, what's my y value? So far I'm good, right? Okay. For this x coordinate, there's just one y coordinate. Is what? 3. When x is 4, what's my y coordinate? I'm good so far. When x is 7, what's my y coordinate? Now I'm going to go towards this 3, though. I'm not going to write a separate 3 since I already have it. But it's still so far a what? A function. Because when x is negative 2, what is my y coordinate? 3. When x is 7, what is my y coordinate? 3. So when x is negative 2, there's only one y coordinate. It is what? 3. When x is 4, there's only one y coordinate. It is what? 6. When x is 7, there's only one y coordinate. It is what? 3. When x is 0, there's only one y coordinate. It is what? When x is negative 1, there's only one y coordinate. It is what? 2. Is that a function? Yes. So sometimes it may help if you draw a mapping to help you. So this is a function. So remember, it's okay to have the same y coordinates as long as the x coordinates are different.
No X.
This is a function since for each x coordinate there is only one y coordinate. Okay? All right, let's look at this one. I suppose we had this.
I thought for each x coordinate, there is exactly only one y coordinate, so we have,
That's what I have, since for each x coordinate is only one y coordinate. What's wrong? That's what I have. For each x coordinate is only one y coordinate.
so if there was multiple 4s on the x side, it would not be a function.
Correct.
Yes, it would not be a function. So let's look at this example. You have to use the definition.
I said no X can be the same, and I highlighted it.
Well,
That's how I understood it.
okay. Don't memorize. You gotta know your definitions. Memorization always comes back and hurts you at some point. You gotta understand it. 4, 3. Negative 2, 7. 4, 6. 8, 0. Yeah. 4, 6, and 8, 0. Is this a function? Not a function. It's not a function. If I use a mapping, when x is 4, what's my y value? 3. So far I'm okay, because there's only one arrow coming out of 4. When x is negative 2, what's my y value? So far I'm okay. But I'm going back now to the next one. It says when x is 4, I already have a 4 listed, so use that 4 that's already there. When x is 4, what's my y value? 6. Right away I can stop because I notice that when x is 4, there is more than one y value. And so right away, I don't even have to look at the 8, 0 anymore. So it's not a function. So you would say not a function, but if it's not a function, you got to tell me why. Not a function since when x is what? 4, there are 2 y values. All right, so there's got to be how many y values? 1. So if you go back to the mappings, for each x, when it was a function, for each x, there was only one arrow coming from that x. Here, we're now in a situation where for x is 4, there's more than one arrow. Okay? All right. So any question on what to do when you have a set of ordered pairs? Okay. Now let's look at the graph. Someone earlier mentioned about the x and a y. So there's x and a y. She said then it's always going to be a function. Well, if you go back to your graphs, when last week when we did the x and a y, and we did mention this, we said when we talked about slope, we said when there's an x and a y, either the graph's going to do what? Rise or it's going to fall. Okay? If it's just y equals, the graph's going to do what? Yeah, but it'll be horizontal. Good. When it's x equal, the graph is what? Vertical. All right, so let's go back to what she mentioned. When there's an x and a y, she says it's always going to be a function. All right, so let's talk about that. So in that case, then the graph would either rise or it would do what? Fall. And so we're going to talk about that in terms of the definition of a function. The definition of a function said for each x coordinate, there's what? One y coordinate. All right, so for this x coordinate right here, you got to look at this in terms of it being in general terms. For this x coordinate right here, and I look at the point, y'all agree that this point goes with this x? How many y coordinates are here? Just one. For this x coordinate, if I look at this point, how many y coordinates are attached to it? Just one. For this x coordinate, if I look at this point, how many y coordinates are attached to it? Just one. So for each x coordinate, there's just what? One y coordinate. Same thing here. For this x coordinate, there's only what? One y coordinate. For this x coordinate, there's only one y coordinate attached to it. There's something called the vertical line test. Vertical line test. Now listen carefully to this. Whenever you're given a graph, you can use a vertical line test to determine if it represents a function. It's very easy to do. All you do is you draw a vertical line everywhere. Just like this. Draw a vertical line everywhere. If that vertical line intersects the graph once each time, then it's a function. That means that for this x coordinate right here, I only have what? One y coordinate. For this x coordinate right here, I only have what? One y coordinate. So a vertical line test, if it intersects the graph once everywhere, then it represents a what? Function. So this is what I said. If a vertical line intersects the graph once everywhere, it is a function. And it all goes back to the definition. For each x, there's what? One y. Now let me show you one that's not a function. You're going to see why. I'm going to draw a graph that's not a function. I want you to see why. Y'all agree that's a relation? A circle is a relation. Now next semester in college algebra, you're gonna graph circles. You're gonna be given an equation with a circle. You have no idea what that looks like. You're gonna be given an equation with a circle, and you have to graph it. That's the beginning of the course. But in this course, you know that this equation is not a what? Function. Because when I just draw the line here, it automatically intersects at how many places? Two. Now let me show you what that means. For this x coordinate, how many points are attached to it? That one and that one. What do you notice about the y coordinates of those 2 points? Same or different? Oh, different.
Because one's positive, one's negative.
One's positive, one's negative. So for that x coordinate, there are two different what? Y coordinates. So you see it's not a function? All right, so that definition of the vertical line test go hand in hand. So a circle is not a function. It fails the vertical line test. I'll just call it DLT. Intersects it, yes.
So 0, 0 wouldn't even be a function.
No, what do you mean 0, 0? 0, 0 is
Like,
just one
say-
point.
Yeah, that's what I mean in something else. Like say, okay, you know how we've been doing, like say y plus 3 equals 5 on a previous problem?
Okay?
And then like we use the x and y 0, 0, and then we use 0 and 2. Would that be a function equation? Well, problem?
She's going back to the one where it was like y equal 2x or something,
Well,
and then you
y-
did the
yeah,
and you did the intercepts, and there was only one intercept.
Yeah.
But y equal 2x is still a function.
Oh, okay.
It's a line with a y and an x in it.
Okay.
In fact, it rises. But I guess her question becomes this: is when we really talk about relation, we're in terms of a function, we're talking about more than one ordered pair.
Oh, okay.
So I guess hypothetically you can have just a relation being one
0, 0.
ordered pair. But for that x coordinate, when x, if I use the mapping, when x is 0, what's my y coordinate? It's theoretically still a function. When x is 0, there's only one y coordinate. It is what? 0. So that would be a function. All right, now, you're welcome. What about, we're about to start graphing quadratics. We're going to do that next class period. But remember, quadratic looks like this. It's a problem. Are those quadratics that, now next semester, you're going to see what those equations look like for something like this. Next semester. In here is going to be a little bit more simpler. But regardless, I'm giving you the graph. Is that a function, not a function? It's a function. Because no matter where you draw the vertical line, it intersects at what? Once each time. So for each x coordinate, there will be what? Just one y coordinate. So a quadratic equation is a function. A quadratic equation is a function. So next class period, we're going to, I'll give you, and we're only dealing with simple quadratic equations here. Next semester, they become much more complicated. But you have to know what the equation kind of looks like in order to do transformations next semester. Next semester, you're going to do transformations. Now, if I had this, now this is not quadratic, although it looks like it. You're not going to graph anything like, you're not going to be dealing with anything like this in terms of equations next semester, but if you did, would that be a function, not a function? It's not a function. It fails the vertical line test. All right, so that will not be a function. But do you see how to use the vertical line test? That's not a function. Okay? Okay. Let's see. I think I can give you one worksheet. Okay.